All right, welcome back, chemistry people. We're going to do some quick guided practice problems to learn how to balance chemical equations to follow the law of conservation of mass. All right, as we take a look at question number 2 here, things get a little trickier because we're given the word equation, which requires that we first write the formula equation before we balance. So we have some solid aluminum, easy enough, is mixed with aqueous lead to nitrate. Again, that may take a little more practice when it comes to nomenclature. This is aqueous. It says the aluminum replaces the lead. Solid lead and aqueous aluminum nitrate are formed. So we've got solid lead, again, pretty easy. And then aqueous aluminum nitrate, AlNO3, 3. And it's aqueous. Now we need to first look and see if this is balanced as is or if we need to add some coefficients to balance things out. I'm going to show you here how you most likely will do it on a given quiz or a test because typically you don't have a bunch of fun little circles to move around your screen. So if you first divide your equation at the arrow, so you have the reactants and the products, we want the same amount of reactants and products on either side of the reaction. I'm just going to make a list of my elements, aluminum, lead, and then I'm going to keep the nitrate together. And you can do that when the polyatomic ion appears on each side of the chemical equation. I'm going to make that exact same list on the product side, Pb, and my nitrate polyatomic ion there. And then I'm just going to count them up. Initially, I've got 1 mole of aluminum, 1 mole of lead, 2 moles of nitrate ions. On the product side, it's 1, 1, and 3. So my nitrates are unbalanced here to start with. I need to add some coefficients where I think it will give me a balanced number of nitrates on either side. I compare 2 to 3. I think to myself, what coefficient can I add in front of these to make sure I've got the same number of nitrates on either side? 3 and 2. And again, as you're working on your test, because you don't have necessarily a bunch of circles to move around, the easiest thing to do is just multiply your coefficients all the way through. So I have 3 times 2 nitrates, so I have a total of 6 nitrates now. Similarly, on the product side, I have 2 times 3 nitrates, so I have 6 nitrates on this side as well. However, recognize that has changed my number of leads on the reactant side to 3 and my number of aluminums on the product side to 2. So I've balanced my nitrates, but I have unbalanced aluminum lead in the process. These are a little easier to do. I've got 2 aluminums on the product side. I'll put a coefficient of 2 here to balance my aluminum and a coefficient of 3 here to balance my lead. So as I look at what I will do to balance a chemical equation on my test, it's going to be just making a quick list of the elements and polyatomic ions, and then it's just a matter of trial and error until I get the law of conservation to work out. All right, we're going to do 2 last problems here. These last 2 problems of the guided practice are asking you to sort of combine what you know about classification of reaction with the balancing of a chemical reaction. As I take a look at guided practice problem number 3, I am given my reactants and I'm told that it's a single replacement reaction. Okay, this is a little trickier. I recognize that sodium is going to replace one of these elements. Sodium forms a positively charged ion, so it's going to replace the other thing that's positively charged, in this case, iron. So I'm going to form sodium bromide, NaBr. To recognize that it's a 1-to-1 relationship when these things form a compound, and the iron is going to be kicked to the curb. Okay, so once I've figured out what my products are going to be, I need to just do what I did. I just need to complete the same process that I did up above. I'm going to divide my reaction into reactants and the products. I'm going to make myself a little list. We've got sodium, we've got iron, we've got bromine. And you want to make sure that whatever list you make on the left-hand side, you make that same list in the same order on the right-hand side. It just makes it a little easier for comparison purposes. You count things up. I've got 1, 1, and 3 on the reactant side, and I've got 1, 1, and 1 on the product side. Now it just becomes a matter of balancing these things out. I need to add a coefficient of 3 in front of my sodium bromide to balance out my bromine. Keep in mind, though, that coefficient of 3 will also change my number of sodium to 3, and therefore I'll need to add a coefficient here to balance that one out as well. I take a quick scan here. I recount my elements to make sure I've got everything following that law of conservation of mass. We do. My final coefficients are 3, 1, 3, and 1. You don't have to write the ones in, but I'm going to write them in for clarity on this video. Okay, now the last guided practice number 4, we've got some compound that I have no idea how to name, and oxygen, and I'm told that this is a combustion reaction. Well, in combustion, I should recognize that my products are going to be carbon dioxide and water. Okay, so it's really important that you understand what your classifications of reactions are telling you so that you can write the products in a given chemical equation. Then it becomes a matter of just dividing my equation into my reactants and products. Make a list: carbon, hydrogen, and oxygen. Carbon, hydrogen, and oxygen. I'm just going to count up how many of each of them I have. I've got 2 on the reactant side, 4 on the reactant side, and be careful here, a total of 4 oxygen on the reactant side. I do the same thing on the product side, 1, 2, and be careful here, 3. 2 from here and 1 from here. So I've counted everything up. Nothing is balanced. Where do I begin? Save oxygen and hydrogen for last. Let's do the carbons first. So I'm going to put a coefficient of 2 here that balance out my carbons. However, it also changed my total number of oxygen to 5. Got the 4 here plus the 1 here. Great. I balanced my carbon. My hydrogen and oxygen are still unbalanced. Which one should I balance next? You're going to want to try and balance the one that appears once on either side. A little easier to do. In this case, the hydrogen. So to balance my hydrogen, I'm going to put a coefficient of 2 here. That gives me a total of 4 hydrogen. And watch out, it gives me a total of 6 oxygen. So my final balanced chemical equation, 1, 1, 2, 2. And we're balanced.